we look to the specification of causal reliable broadcast. Here is our causal broadcast abstraction. We have, this is the name of the module, causal order. We have the events as usual, the broadcast event and the deliver event. And we have what we call the causal broadcast property, which says if some node Pi delivers a message M1, then Pi must deliver all causally preceding messages before M1. Let us look to the interface one more time. This property, which we call it the causal broadcast property. One question is, this property completely describes what is a causal broadcast, and is it in itself only by itself useful? And the question is, how can we satisfy this property? The answer is, if you look carefully, this is only a safety property, and safety can always be satisfied by never doing anything. So you can satisfy this by just not delivering any messages. And that guarantees that you will never violate the causal order properties. Let us also look to two different possible formulations of the causal broadcast property, and I guess everybody would have first thought that the right way to specify a causal broadcast is by this property that I just pointed to, which is if a process delivers M1 and M2, delivers two messages, and M1 causally precedes M2, then Pj must deliver M1 before M2. So we have now two possible ways to formulate the causal broadcast properties, and the question is, what is the difference between these two? I think the issues that we are going to discuss is, does Cp imply Cp prime, or Cp prime implies Cp? And we are going to also to see if Cp prime is a property that we want or not. Here is two scenarios. We call this scenario A, and this is scenario B. We look to A first. We have three processes. P1 broadcast message M1, which causally precedes message M2, which causally precedes message M3. So what we have is M1 is before M2, which is before M3. And we can see, if we just look, say, for example, to P1, that M2 is delivered before M1. And in this case, both messages are delivered, but this delivery violates both CB and CB prime. Now, let us look to this scenario. Again, we have M1 is before M2, which is before M3, but we have a situation where message M1 is not delivered at P3. So the message does not arrive. In this case, this is really not a satisfactory execution that we would like to have. And this execution indeed violates CP, but does not violate CP prime. Look here, why it does not violate CP prime? First, because CP prime requires in the precondition that two messages are delivered, but M1 is never delivered. So, whereas CP says if this message, which is M2, is delivered, then all preceding messages should be delivered. In this case, M1 should be delivered. So indeed, what we have is CP implies CP prime, but CP prime does not imply CP, because here we have a situation where CP prime is true, but CP is not true. So here is the specification of the module, reliable causal order broadcast. And in this specification, we use CP, but CP is not enough. We are also using the properties of a reliable broadcast: the validity, the no creation, no duplication, and the agreement. And the validity gives us basically the liveness that we need. If we want to define a uniform, reliable causal order broadcast, we just use the CP property and the uniform reliable broadcast properties. That's it. In fact, this just gives us an idea about how to implement causal broadcast in the different forms: the regular, reliable, or the uniform, reliable. And that's what we're going to do. We are going to use reliable broadcast to implement a reliable causal order broadcast, and use uniform reliable broadcast to implement a uniform causal broadcast. So our causal broadcast will use a reliable broadcast in the implementation to have a regular reliable causal broadcast, and it's going to use uniform reliable broadcast to have a uniform causal broadcast.